Have you ever wondered if we're truly alone out there? Not just in our solar system, not even in our galaxy, but in the entire universe? Every so often, astronomers point their telescopes toward a distant patch of sky and find something that makes them stop and think, could this be it? In 2023, something extraordinary was found orbiting a quiet red dwarf star over 130 light-years away, a planet not too hot, not too cold, sitting right inside what scientists call the habitable zone. But here's the twist. It's not just one planet. It's an entire system. And what makes it even more fascinating? We have the tools, right now, to study its atmosphere. This could be one of our clearest chances yet to spot the signs of life beyond Earth. The star at the center of this story isn't bright. It doesn't blaze like our sun or dazzle like a blue giant. In fact, most people, even most astronomers, had never paid much attention to it. It's called TOI-715, a cool red dwarf located about 137 light-years from Earth in the constellation Volans. These types of stars, known as M-dwarfs, are the most common in our galaxy. They're small, stable, and they live incredibly long lives, sometimes trillions of years. But what makes TOI-715 special is what was found orbiting it. In 2023, NASA's TESS mission, the Transiting Exoplanet Survey satellite, spotted a very slight dip in the star's brightness. That tiny flicker was a clue. Something had passed in front of the star. That something turned out to be a planet. A planet slightly larger than Earth. And later, signs of a second world emerged. One possibly sitting right at the edge of the habitable zone. Finding planets light years away might sound like science fiction, but the way we do it is surprisingly clever and incredibly precise. NASA's TESS mission, short for Transiting Exoplanet Survey satellite, is designed to look for tiny shadows, not spaceships, not signals, just shadows. It constantly watches thousands of stars at once, waiting for the moment when a planet crosses in front of its host star. When that happens, the star dims just slightly, sometimes by less than 1%. But that's enough. By measuring how long the dip lasts and how often it repeats, scientists can figure out the planet's size, shape, and orbit. TESS doesn't take detailed photos. It's more like a cosmic light meter, measuring brightness every second across vast regions of the sky. And that's how it spotted the subtle signal coming from TOI-715. A planet blocking just a tiny bit of starlight, but telling us a massive story. The test data revealed not just one, but two planets orbiting TOI-715. The first, TOI-715b, is a super-Earth. That means it's slightly larger and more massive than our planet, about 1.5 times the Earth's radius. It orbits its star in just 19 days. Sounds fast, but remember, the star is much cooler and smaller than our Sun. So even a close orbit doesn't mean scorching temperatures. In fact, models suggest TOI-715b may be cold, but not frozen beyond hope. With the right atmosphere, it could theoretically hold liquid water. Then there's TOI-715c, a planet candidate still waiting for full confirmation. But based on current data, it appears to lie right in the habitable zone, the sweet spot where temperatures might allow for oceans. This is where things get exciting. If TOI-715c is confirmed, it would become one of the closest known potentially habitable exoplanets. Close not just in distance, but in how observable it is. A perfect target for telescopes that can study atmospheres, climates, and even possible biosignatures. When scientists talk about life on other planets, they often mention something called the habitable zone. It's not a magical region where life just appears. It's simply the distance from a star where a planet could, in theory, have liquid water on its surface. Too close, and water boils away. Too far, and it freezes solid. Earth sits comfortably in the habitable zone of our Sun. Venus is just a bit too close. Mars, a bit too far. But for cooler, smaller stars like TOI-715, the habitable zone is much closer in. That's why TOI-715c, even though it orbits its star in just a few weeks, might actually be in the right spot. And here's the key. A planet in the habitable zone isn't automatically habitable. It needs an atmosphere. It needs the right pressure. Maybe a magnetic field. But the zone itself, it's the first green flag, the starting line in the search for life. So let's ask the big question. Could life, any kind of life, really exist on a planet like TOI-715b or TOI-715c? The answer is, we don't know, but we do have reasons to stay curious. First, size. Super-Earths are among the most common types of planets in the galaxy, and yet we have 0 examples of them in our own solar system. That means every discovery gives us something entirely new to study. If TOI-715b has a thick atmosphere, maybe with clouds, greenhouse gases, and internal heating, it could support temperatures far milder than we think. It could have oceans, maybe continents, maybe something even stranger. And TOI-715c, if confirmed, is even more intriguing. Sitting in the habitable zone, it might receive just the right amount of energy. The question is, does it have the right ingredients? Carbon, water, a stable climate. Life doesn't need to look like it does on Earth, but it does need some kind of chemistry to build from. And that's what missions like JWST, the James Webb Space Telescope, are about to help us figure out. The James Webb Space Telescope isn't just a better version of Hubble, it's something entirely different. Designed to see in infrared, JWST can peer deep into dust clouds, detect distant galaxies, and, most importantly for us, analyze the atmospheres of exoplanets. When a planet like TOI-715b passes in front of its star, a tiny bit of starlight filters through its atmosphere. If it has one, that light carries a fingerprint. JWST can read those fingerprints. It can tell us if there's water vapor, methane, carbon dioxide, maybe even ozone. These aren't just chemical curiosities, they're potential biosignatures. On Earth, life leaves chemical traces. Oxygen in our atmosphere, mostly from photosynthesis. So if we detect similar compounds on another planet, we'll need to ask, what put them there? Was it geology, volcanoes, or biology? When JWST or another telescope collects light from a distant planet, the real work is just beginning. Scientists break that light down, literally, into its component wavelengths. This creates a spectrum, a kind of barcode that shows which gases absorbed specific colors of light. For example, if there's a dip in light at the 1.4 micron band, that's water vapor. If it drops at 2.3 microns, maybe carbon dioxide. And if multiple markers line up, water, methane, maybe even oxygen, that's when eyebrows go up. But it's not so simple. Some of these gases can come from volcanoes, others from photochemical reactions. That's why scientists look for patterns, combinations of chemicals that are hard to explain without life. For instance, on Earth, oxygen and methane coexist in the atmosphere only because something is constantly replenishing both, mostly plants and microbes. So when we analyze alien worlds, we're not just searching for a single molecule. We're searching for a story in the chemistry. A story that says, something unusual is happening here. TOI-715 isn't the only system that's captured astronomers' attention. In the past decade, we've discovered dozens of planets that just might, be capable of supporting life. One of the most famous is TRAPPIST-1, a system of 7 rocky planets orbiting an ultra-cool dwarf star just 40 light-years away. 3 of those worlds lie in the habitable zone. Then there's Kepler 186f, the first Earth-sized planet found in the habitable zone of another star. It's about 500 light-years from us, and its discovery, back in 2014, was a major milestone. Others followed, LHS 1140b, a dense, potentially ocean-covered world. Proxima b, orbiting the closest star to our Sun. Each of these planets is different. Some are larger than Earth. Some get blasted by stellar flares. Others might be tidally locked, with one side always facing their star. But they all have one thing in common. They challenge our assumptions about where life might exist. And with every new system we study, like TOI-715, our picture of the universe gets a little bit sharper, Not emptier, but richer, more alive. For most of human history, the idea of other worlds, let alone life on them, was just speculation. But now, we're finding planets by the thousands. Some are scorching hot. Others are frozen. But a few sit in just the right place. TOI-715b and possibly TOI-715c are part of that short list. They're not just numbers in a catalogue. They're invitations to ask new questions, to build better tools, to really look at the light coming from distant suns and search for meaning inside it. We don't know yet if these planets hold life, but we're getting closer, not just with technology, but with perspective. The universe is vast, but it's not empty. It sings in light, in gravity, in time itself. And somewhere, perhaps circling a quiet red dwarf, 137 light-years away, life may already be watching the stars, wondering if it's alone too. Maybe we're not searching for answers. Maybe we're searching for reflections.